So normally examples for Alexa skills are within AWS Lambda functions, but we've had enough requests regarding how to deal with Azure Functions that I thought I'd just do a quick Hello World example of how to get an Azure function interacting with a newly created Alexa skill. So let's see how that works. So my IDE of choice is Visual Studio Community Edition 2019. I just go to File, New, and I have the Azure projects selected, one of which is an Azure function. So when we create the project, we need to pick an HTTP trigger so that we end up with a URL that Amazon can send its requests to. I don't have an option for the storage emulator in this point. I'm just sending a response regardless of anything else. And we need anonymous access to the function. We'll go into security in a little bit, but the important thing is Amazon need to be able to make this request without any authorization. So we need to add Alexa.net to the NuGet package list for this Azure function, but if you try and do that with the latest version of Alexa.net, what you'll get is an error, and that error is that we need to update the version of JSON.net that is being used. So first of all, we update the Newtonsoft reference to the Azure function. I'm just going to pick the latest, and then we can add Alexa.net to the NuGet package list as well. So we're going to start refactoring the templated method, get rid of the code before and after this deserialization. I'm going to keep the get method in. It's not required for Amazon, but in this case, it's just so we can use the browser, send a get request to make sure the function's active. So we're going to just put a message in there so that the get responds with an OK object result, but it's not actually going to do anything. Then we're going to rely on the JSON convert deserialization to create a skill request. So this is the JSON coming in from Amazon. You will see some examples where the strongly typed objects are put directly into the method signature. We don't do that for Azure Functions because we rely on some of the JSON.NET complexities, and JSON.NET isn't being used at this point to deserialize the object. So we just get the stream or string from the request object and then use JSON convert, JSON serializer to be able to ask for a skill request object. As we're not using Lambda, we are going to have to put an extra couple of lines in code compared to the AWS version. This is for security. So there are two things with the skill request we have to check. The first is that the timestamp on the skill request is reasonably close to the current timestamp. This is to make sure that people aren't trying to send old requests where they've figured out some of the information. The second thing we do is with non-Lambda requests, Amazon sends some headers, and that's regarding the signature for the skill request body, and also a certificate URL, which we can then use to verify the signature. This is all wrapped up in a request verification class, so it's done for you. So here I'm adding a couple of lines of code to pull out the headers, and then running that verify method on the body string that we've already extracted. I will put a link into the YouTube description for a much more comprehensive method that works with this and does validation on the headers being there and that kind of thing. But this is just to get it working. I know this is going to work because I'm the only one sending the requests, and they're going to be coming from Amazon, so I know these headers are going to exist. Now we've used the skill request to verify the signature and check the timestamp. We're not going to go into the details of the skill request, that's for another screencast. In this one, we simply want to return a response that the Amazon system can send to the Alexa devices. So we're going to use the response builder class. This is probably the most common way you're going to get a response for your skill. And it's a bunch of helper methods that rely on the idea of ask and tell. So if you ask something, then it's a response where you expect the user to talk back. And tell is a response where you're making a statement, and then that's just going to end the session with your Alexa skill. We're going to use tell in this case because we're not going to do the conversation element in this screencast. And then we're going to put that into an OK object result, and that will handle serializing the object and sending that back to Amazon for us. So now that's done, I'm going to publish this function. I'm going to use the settings that come up, but obviously you'd get your own options come up from your resource groups inside your Azure account. And then I'm going to allow that to publish that. And then based on the URL, I'm going to have a look and just hit function 1, and that get endpoint should work. And it doesn't, so I'm gonna just have a quick debug session. Not going to bore you with that. Okay, so after checking everything, turns out that I needed to build the skill first. It did actually publish an Azure function for me, but with no functions in it. So now I've rebuilt and republished. I can go to function 1. And we see the get endpoint is working, saying that it has to come from alexa.net. So now we've got our working endpoint, we can go to the Alexa skills dashboard. So go to developer.amazon.com, then go to Alexa and then skill console. And then we create a new skill. In this case, the defaults are fine. We're self-hosted. We want a custom skill. We want to start from scratch because we've already written our own code, and that will bring up the IDE for us in terms of making changes. From here, we can go to the endpoint tab, and then we want to pick and say that we're doing HTTPS. You get an option for the number of the kind of certificate that you've got. So you paste in your URL, and then for the Azure Functions, in the default case, we are a subdomain that has a wildcard certificate, and this is just so that Amazon knows how it's going to handle its certificate checking. And then we are set up for the endpoint. So now the endpoint's set up, just need to check the invocation name. If you've set it up as hello world all one word, then there'll be an error at this point. And basically that's because the invocation name has to be at least 2 words. So when you say Alexa open and then put your skill name, that name has to be 2 words. In this case it's fine, it's hello world as 2 separate words, but there's still a problem, which is the fact that we haven't asked it to look for any phrases, any intents. Not going to go into intents in this screencast, that's for a later screencast. So for now, we're just going to go to the intent screen and create a new test intent. Every intent has to have at least 1 phrase, so we're going to put test in there as well. And then that's the last problem that should get raised, so we should be able to build the skill. Building happens in 2 parts. It does a quick build and then a full build. Because we want to test in the test tab in the IDE, we need to wait for the full build to complete before we can use that part of the system. Okay, so when we go to the test tab, you'll see for a new skill that testing is off by default. You can pick the environment you want the IDE to test against. We've only got the development environment for now, so we'll use that. And then you can use the microphone attached to your computer, but I prefer the keyboard, so I'm just going to type in the words open hello world. So this is exactly the same as saying Alexa open hello world against the microphone or with a real device. And then as we'll see, we've got a large JSON blob on the left hand side. So that's our skill request. That's what's being sent along with the headers that we need over to our Azure function. And then we are getting a response as shown in the dialog on the right hand side. That's our skill response. So that's coming from our Azure function. And so there we go, that's a working Azure function with an Alexa skill. Now obviously it's missing a lot of logic, it's not actually doing anything, but right now you've got something that can communicate 2 ways, and so it's something you can then build on. And we'll go into that in future screencasts, so see you then.